Today we are going to make a line follower. The car will automatically follow the black line however you keep on the surface. The components required are brain, ESP, IR, chassis, battery, biomotors and wheels. Now we'll be starting with assembly. Now take the car and two IR sensors and keep the two IR sensors before the C structure and fit those two by using nut and bolts. Now we have assembled the body, connected the motors and sensors, and now it's time to bring it to life with a code. And this first part is called importing libraries. These are like toolkits that helps us do special things. Like we have to take the libraries like this. Here, pin is for connecting sensors and motors. I2C helps us talk to motors control chip. Then we are also importing the library called time. It is for making the robot wait or pause when needed. And now here we are connecting the two IR sensors to the car. Pin off. Here we are telling the robot sensor 1 is on pin number 0 and will be the left eye, and sensor 2 is on pin number 2 and will be the right eye. We use pin.in because these are input pins. The robot is receiving data from them. Let's understand what these sensors tells us. If a sensor sees a black line, then it gives the answer as 0, and if it sees a white line, then it gives a number called 1. This is how our robot knows where the line is. Here comes the main loop. It tells the robot keep checking the line again and again without stopping. And here we have to read the values from both sensors. We are storing those values in two variables called IR1 and IR2. In IR1, it is a variable that stores the left sensor's value. IR2 is a variable that stores the right sensor value. Variables are like small boxes that hold data for us to use later. And now we have to decide what to do based upon the values we got. Here, if both IR1 and IR2 are getting value 0, that means both sensors see black color. That means the robot is right on the line. So let's move forward. And now here we set up the PCF chip. This is called a small chip that controls the motors. We use I2C to talk to it using just two wires. And here we have to connect it from ESP to PCF like these commands are used to communicate between ESP and PCF chip. And this write expander is a function. This sends a number to the chip to control the wheels. And here we are connecting the pins D1 and D2 to the two pins of PCF input. And now we can call our function and send the values to the PCF to control the motors. Now if both IRs are seeing black, then it is 0 on both sides. So it will tell like and we are printing the command on which it is working. And now we call our function and sends the value to the PCF, and this tells both wheels to move forward. And if the left sensor sees black, and the right sensor sees white, the line is on the left side. So the robot needs to turn left a little. We also add a tiny pause with time.sleep to make it smooth. We are also printing the statement called turning left. Now the next condition is turning right. And here the IR1 will be 1, IR2 will be 0. If it is, you have to write the command like and we are going to print it as turning right and time sleep for 0.05. That means if both sensors see white, then the robot is off the line. So we stop the motors and wait a little. And let's make a quick recap. We connected two sensors as the motor eyes, and we used two variables to read the sensor values. If both sensors sees black, the motor went forward. If the line was on one side, it got turned in the following instructions. And if no line was seen, then the car is entirely stopped. And we spent special numbers to a motor chip to make it all work. And we sent special numbers to a motor chip to make it all work. After writing the main code, save the file as main.py on your ESP8266. This file runs automatically when the board is powered on. It controls how your smart car behaves. You can make your own car track by using a black tape on your floor.